Hey, I'm Tiffany Velasquez, and today I'll be going over my Unit 4 case connections. So I chose to do case connection number 2 and number 3, and I will go over case number 2 first. So in case number 2, the subject and the presumptive diagnosis is phenylketonuria, which is a genetic metabolic disorder that creates complications when consuming any product that contains aspartame. And it involves a lack of the enzyme phenylalanine hydroxylase, which is needed to metabolize an amino acid called phenylalanine, which is an essential amino acid. PAH converts the essential amino acid phenylalanine into tyrosine using the cofactor BH4. A deficiency of the enzyme leads to increased levels of PHE and normal to decreased levels of tyrosine in the blood and in the tissues. Tyrosine becomes an essential amino acid because it cannot be synthesized by people with PKU and is needed for protein and dopamine synthesis in the brain. Increased levels of PHE in the body when ingesting food that contain it can lead to central nervous system and brain damage. PHE is found in high protein foods such as meat, dairy product, nuts, beans, and sweeteners found in diet soft drinks. It is possible that you never noticed. I know that I never did, but this is why there are warning labels on soda cans and other food products that state that the product contains phenylalanine. A low-protein diet is suggested for individuals with PKU since PHE isn't properly digested and concentrations will build up in the blood, form phenylpyruvic acid, which, as noted before, can lead to brain damage. As explained in the case study description, patient A is a 4-day-old infant whose newborn screen revealed high levels of PHE in the blood. The patient was put on a PHE dietary restriction at 14 days of age, and plasma levels of PHE dropped to normal levels. This drop in PHE levels after a dietary restriction helps confirm the diagnosis of PKU and phenylketonuria. Potential causes of the presentation of phenylketonuria include the mutated genes passed down from each parent. Due to the genes being passed down, another cause could be due to the kind of formula that was given to the infant if it contained phenylalanine. Both patient A and patient B were administered BH4 loading tests. And I found during my research on this topic that the current definition of BH4 responsiveness is based on the decrease of blood PHE, approximately around 20 to 30%. Given that information and based on evaluation of the graph, patient A is unresponsive to BH4 loading due to an inconsistent increase in PHE levels. Patient B is responsive to the BH4 loading, as shown in the graph, by decreasing levels in PHE over time. The administration of BH4 should increase the rate of PAH activity, convert PHE into tyrosine, and overall lead to decrease in levels of PHE in the blood. I will now move on to case number 3. So gout is a very common form of arthritis that affects the joints. It is characterized by sudden attacks of pain along with swelling, redness, tenderness, and a limited range of motion. These symptoms can occur overnight, and as our patient mentioned, that happened to him, along with pain in his right great toe with no apparent trauma. Gout is a result of urate crystals accumulating in the joints, and this is the cause of the pain and inflammation. Purines are found in certain kinds of meat, food, alcoholic beverages, and drinks sweetened with fructose. When the body breaks down purines, uric acid is produced and urate crystals form when there are high levels of uric acid in the blood. Uric acid is normally dissolved in the blood, passed through the kidneys, and excreted from the body in urine. However, sometimes when the body produces too much or the kidneys do not excrete enough and levels build up, forming needle-like crystals in joints and tissues. Sodium urate crystals in soft tissues. Sodium urate crystallizes in soft tissues when serum urate levels exceed solubility limits, causing inflammatory reactions and gouty arthritis. Abnormal renal handling of uric acid is commonly the cause of gout cases. The patient explains that he drinks up to 5 liters of soda a day. Soda contains carbonated water and sweeteners, and diet sodas contain substitutes such as aspartame, and regular sodas are sweetened with fructose. This dietary intake of fructose is a possible risk factor for this patient's gout. Biochemically, fructose consumption leads to gout by stimulating the catabolism of adenine nucleotides. Studies show that consuming 2 servings of sweetened soft drinks a day increase the risk of developing gout by 85%. The patient's dietary modification of switching from diet to regular sodas has caused a great dietary impact on his health and is likely the cause of his gout flare. The best explanation for the presentation of gout in this individual is decreased urinary excretion of uric acid. The patient is consuming 4 to 5 liters of non-diet soda per day. The high amount of fructose-containing soda increases the number of purines in the body, leading to an increased amount of uric acid in the blood as the purines are broken down. The body is not able to excrete enough uric acid, increasing plasma urate levels, leading to an accumulation in the patient's right great toe, causing gout. A decrease in uric acid, decrease in urinary uric acid, and an increased plasma urate are consistent with his lab results and diagnosis of gout. The patient is not overproducing purines. Purines are broken down, leading to higher levels of uric acid. And if a patient excretes more than 800 milligrams of uric acid, they are deemed a overproducer. The patient excreted 215 milligrams, so that confirms the overproduction of purines is not the cause of their symptoms. Nucleic acids are recycled in the body, and this salvages free purines, which can be used to make new nucleic acids. The breakdown of DNA or RNA causes free purine salvage. Deficiencies in the enzyme hypoxanthine transferase prevents proper purine salvage. Testing for the presence or absence of this enzyme is needed since the laboratory findings are similar to that of having a decrease in urinary secretion of uric acid. Okay, well that concludes my presentation. Thank you for your time.